Hello student, this video is for class 9th student, and in this video we will cover chapter number 8. The chapter name is motion. So let's start. First topic is rest. A body is said to be in state of rest when its position does not change with respect to a reference point, or you can say with respect to time. If a body does not change its position with reference to a stationary point or reference to a time, then it's said to be in rest. Motion. When a body changes its position or change its position with respect to a reference point or with respect to time, then the body will said to be in motion. A body is said to be in the state of motion when its position changes continuously with a reference to a point. Now, motion can be of different type depending upon the type of path by which the object is going through. It means depending upon the path on which the object is moving, motion can be of different type. First type of motion is circulatory motion. When an object move on a circular path, then the object is said to be in circulatory motion. Like Earth rotate around the sun. Then we will say that Earth in circular motion. Second type of motion is linear motion. When an object moves on a straight line, then it is said to be in linear motion. Like a car is going on a straight road, or an athlete who is running into a 100-meter race, then it is said to be that the athlete is possessing linear motion. Third type of motion is oscillatory motion. In this type of motion, the object move to and fro with respect to its origin. It means when an object move to and fro about its mean position, then it is called oscillatory motion. Like an example with pendulum of the wall clock. Now, scalar quantity. It is the physical quantity having on magnitude but no direction. It means scalar quantity have magnitude but no direction. Like example, distance, speed. Distance and speed are scalar quantity. They have only magnitude but does not require any direction. Vector quantity. It is the physical quantity that requires both magnitude as well as direction. Example, displacement and velocity. So vector quantity are those which contain both magnitude and direction. Examples are displacement and velocity. Now, the next topic is distance and displacement. First, we will cover distance. The actual path or the length traveled by an object during its journey from initial point to the final point is called the distance. Distance is a scalar quantity which requires only magnitude but no direction to explain it. Example, Ramesh travelled 65 km. Distance is measured by odometer in the vehicles. Suppose an object is here at the position A and it go into the straight line at the position B. Then the distance will be from A to B like 50 meter. Then we said the object cover 50 meter distance. If it will return to a point C, which is 30 meter from B, now the total distance will be 50 plus 30. It means 80 kilometer or meter. Now the next topic is displacement. Displacement is a vector quantity which requires both magnitude and direction for its explanation. Example, Ramesh travelled 65 km to southwest from clock tower. It means in this case both direction and the distance is required. So displacement contains both magnitude and direction. So how we will explain the travelling of the Ramesh? North, south, east, and west. It means Ramesh traveled 65 kilometers to southwest from a clock tower. Suppose the clock tower it at origin and Ramesh travel southwest 65 kilometers. So this will be the displacement. It means it contain both magnitude and the direction. Displacement can be zero when initial and the final point of the motion are same. It is the point to be noted that displacement can be zero when initial and the final point of the motion are same. Suppose an object is traveling on a circular path, then it can be that its final position and initial position will be at same. So the object will set to be in circular motion and the displacement will be zero. Differentiate between distance and displacement. Distance. Length of the actual path traveled by an object is called distance. It is a scalar quantity. It remains positive, cannot be zero or negative. Distance can be equal to the displacement in linear path. Now about the displacement. Shortest, shortest length between the initial point and far point of an object. It is a vector quantity. It can be positive, negative or zero. It means displacement can be positive, negative or even zero. Displacement can be equal to the distance or it's lesser than the distance. Displacement can be equal to the distance or can be lesser than the distance. Now, into this circle, we will see the initial point of the object is A. If it covers half the distance of the circle, then it will reach at the point B. Now the distance will be pi r. The distance will be pi r, which is equal to the displacement. But now see, if the object return to its initial position A, then the total displacement will be 0 because there is no difference between the initial and the final point. But the total distance traveled by the object will be 2 pi r. Next topic, uniform and the non-uniform motion. Uniform motion. When a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. When a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. It means like a car is moving on a straight road, a straight blank road without curve, without any crowd. So the car is covering equal distance in equal interval of time. Then it is said that the car possesses uniform motion, and the graph of the uniform motion will always a straight line between time and distance. Now, non-uniform motion. In this type of motion, the body will travel unequal distance in equal interval of time. So, in this type of motion, non-uniform motion, a body travels unequal distance in equal interval of time. It means body can travel different distance in equal interval of time. So, non-uniform motion can be contained two type of graph. First type of graph is continuous increase in slope of curve indicate accelerated non-uniform motion. When the object speed or you can say the distance is continuously increasing with the time, and the second graph in which the distance of the object continuously decreasing with time. So the uniform motion can be of two type, when the distance and time graph in which there is a decrease in the slope, and another one in which increase in the slope can be seen. Two type of non-uniform motion. First is accelerated motion. When motion of a body increases with time, then it is said to be in accelerated motion. The velocity of time graph will always show accelerated motion. In this motion we can see the velocity is continuously increasing with time. So it is said to be in accelerated motion. Deaccelerated motion, when velocity decrease with the time, then it's said to be in deaccelerated motion. In this graph you can see the graph is pointed downward. It means velocity is decreasing with time. So this is the deaccelerated motion and the upper graph is of accelerated motion. Now the next topic is speed. The measurement of the distance traveled by a body per unit time is called speed. So speed contains the formula speed is equal distance traveled upon time taken. V is equal S upon T. SI unit of the speed is meter per second. If a body is executing uniform motion, then there will be a constant speed or uniform motion. If a body is in uniform motion, then we can say the speed will be constant. There is a conversion factor which you can use to change kilometer per hour speed into meter per second by multiplying them 5 upon 18 meter per second. Average speed. If a body is traveling with non-uniform motion, then the speed will not remain uniform but have different value throughout the motion of such body. Now, if a body is traveling with a non-uniform motion, then the speed will not same with the equal interval of time. So speed will remain change into the every part of the time. So in this case, we will not calculate the speed. For non-uniform motion, average speed will describe one single value of the speed throughout the motion of a body. So into the case of non-uniform motion, we always calculate average speed of the object. So average speed is equal total distance traveled upon total time. This is the formula of average speed. Velocity. It is the speed of a body in a given direction. So velocity is the ratio of displacement, or you can say velocity is the rate of displacement per unit time. So velocity is equal displacement upon time. SI unit of velocity is same as the SI unit of speed. SI unit of the velocity is meter per second or meter second inverse. So when the displacement can be positive, negative or 0, so the velocity can also be positive, negative or 0. Velocity is a vector quantity. Its value changes when either its magnitude or direction changes. It means velocity is a vector quantity and its value changes either its magnitude or direction change. Now the next topic is average velocity. For non-uniform motion in a given line, average velocity will be calculated in the same way as done in the average speed. So average velocity can be calculated by the formula total displacement upon total time. For uniformly changing velocity, the average velocity can be calculated as average velocity is equal initial velocity plus final velocity divided by 2. So the average velocity into the uniformly changing velocity can be calculated by u plus v divided by 2, where u is initial velocity and v is the final velocity. Now the next topic is acceleration. Acceleration is seen in non-uniform motion and it can be defined as the rate of change of velocity with time. When an object is in non-uniform motion, it means velocity is changing with respect to the time, then the motion will be said to be accelerated motion. And the acceleration of the object can be calculated by rate of change of velocity with time. So formula of the acceleration will be change in velocity upon time. Change in velocity, it means it is the difference of final and initial velocity v minus u upon t, where v is the final velocity and u is the initial velocity. If v is greater than u, then a will be positive. If u is greater than v, then A will be negative. SI unit of the acceleration is meter per second square or meter second square inverse. Now retardation. It is also said as negative acceleration. Deceleration is seen in non-uniform motion during decrease in velocity. When there is a decrease in velocity with time, then we will say the object possesses deceleration. It has same definition as the acceleration. Deceleration is equal change in velocity upon time, v minus u upon time. But here is a condition that v is less than u or u is greater than v, and in such condition a will be negative. So deceleration is a negative acceleration. Of motion. There are three equations of motion. First is v is equal u plus at. Second, s is equal ut plus half at square, and the third is v square is equal u square plus 2as. These three equations used to calculate the numericals related to the equation of motion. U is equal initial velocity, v is equal final velocity, t is time, a denoted acceleration, and s denoted to displacement. It is the most important topic of the chapter because it is used to calculate all the numericals depending upon this chapter. Now the last topic of the chapter is uniform circular motion. If a body is moving in a circular path with uniform speed, then it is said to be executing uniform circular motion. In such a motion, the speed may be the same throughout the motion, but its velocity is different at each and every point of its motion. Thus, uniform circular motion is accelerated motion. Now, I am repeat again. If a body is moving on a circular path with a uniform speed, then it's said to be existing uniform circular motion. But in such case, the speed can be same but velocity is changing continuously. Why is the velocity is changing? Because at every instant the position of the object is changing. So when the position of the object or direction of the object is changing, then there will be a change in the velocity. When there is a change in the velocity, then we will say there is an acceleration. So the uniform circular motion is always accelerated motion. Speed of object moving on circular path can be calculated by using the formula speed is equal 2 pi r upon t, where r is the radius of the circular path and the t is time taken to cover the circumference of the circular path.